Thank you for this wonderful discussion. Dr. Simon mentioned the simulation of a black hole on a quantum computer. Now, first of all, I'd like to correct that was not actually a black hole, it was a wormhole.
Sorry.
No. Now, since we know that quantum computers can better simulate quantum systems than classical computers, obviously, there has been this recent proposal called ER equals EPR due to Juan Maldacena and Linus Susskind. One of the consequences of which is the space-time emerges from quantum entanglement. Do you think that in the future we can use quantum computers to simulate the creation of space-time from quantum entanglement? And if yes, how far do you think we are from that?
I don't know. See, I only read these things in this magazine that is called Quanta, which is more than just quantum, and so my knowledge of this wormhole story is not going any deeper than a public sort of interest science magazine that I can highly recommend. So I cannot answer your question, but I believe that, as I said, that some quantum simulations will probably be much more effectively being carried out on quantum computers in the future if somebody, maybe you have interest in this, wrap their mind around how to use the properties of quantum computers to simulate quantum systems directly.
So just to that, I think there's more activity in the community on trying to imagine how you would use a quantum computer to simulate black holes dynamics. I mean, the model of what we understand to be the inner dynamics of a black hole, right? There's lots of things about information scrambling, and you may have heard about the black box information paradox, and there's all type of questions concerning entropy conservation, these type of things. That's a very fundamental discussion. And there's theories that kind of try to answer those questions, thinking about information scrambling and assuming that a black hole is a big scrambler of quantum information. And so if you want to reproduce that type of dynamics, it's very hard to do that with classical computers, and you may want to use a quantum computer for that. I am not so much aware of lots of works going in the direction of simulating wormholes, right? But likewise, I'm not a specialist on that.
The wormhole simulation has to do with that. They used holography, and holography is used to understand the information of black holes.
Okay, I think that there is this attraction of the Hamiltonian. And the Hamiltonian is sort of so attractive as a model that you can think of having the Hamiltonian of something and then having the quantum simulation system as a way, an incarnation of this. And then you will do analogy. For this is an analog, I believe, paradigm. This is just my 2 cents, rather than a numerical. We were thinking, talking a slightly different thing though, using a quantum computer. So it's a different story. You know, there are cases, quantum material, for example, are cases in which I directly simulate through a similar dynamic behavior, and I try to, by analogy, derive the properties that I expect in some real system outside. So the simulator is not the system, but has a similar Hamiltonian sort of. I'm trying to make this type of thing. In a quantum computer, there are many more steps in order to arrive, to use the quantum computer to derive properties, and you require the digital extract. Now, I personally don't know about the direct simulation. I know people who are very fine, and certainly it's very costly, and the quantum computing paradigm sort of promises to be much more general in potentially. I don't know if what I'm saying makes sense. So could you please find sort of a comment? Because what he was saying is, I am so interested in this very complex system. I think that I can create a quantum system whose Hamiltonian will sort of allow me to make the deduction on the main system properties.
Yeah, thanks. So this goes back to the early days of Richard Feynman in the early 80s, where he was saying, like, okay, let's use a quantum computer to simulate another quantum system. Let's not use a classical computer to simulate a quantum system, right? And this is really one of the hallmarks of expected applications of quantum computing. We have seen news this year, for instance, coming from the Google group on simulating with a quantum computer the time dynamics of a molecule, and then this is a classical simulation that is expected to be hard, and at the same time you can measure things that depend on parameters of the molecule and then compare the measurements in your quantum computer with actual measurements that take place in an NMR experiment, for instance. And they claim that they can use this to measure certain intra-atomic distance, this